Hello everyone, my name is Peter Schaknat. I am the Managing Director of Schaknat Electronic GmbH, and today we are optimizing a Mercedes-Benz Actros 1845. A quick overview of today's procedure. We are optimizing a Mercedes-Benz Actros 1845, an OM engine and a 12.8-liter engine. This engine is also available with 420 horsepower, 450, 480, 510 and 530. This one has 450 horsepower and 2,200 Newton meters of base torque. We'll also read out the current software status again. It could be that it even has a top torque, meaning this torque increase in the 11th to 12th gear, but we'll take a look at that together in a moment. This is the company Brugger, a long-standing customer of ours. This is about fleet optimization, also again about fuel consumption, SPN. As always, you can see the fuel prices yourself. It's a complete disaster. So even with the introduction of tax relief, fuel prices are unfortunately just not decreasing, and that's precisely why every single liter of fuel you can save in a transport company is now quite literally worth its weight in gold. You can also see that this is an MP Actros and it's already got some kilometers on it. You know, the widespread supply shortages have forced many people to purchase used trucks at the moment, and that's precisely what the company Brugger decided to do. Interestingly, it's actually an Austrian company, but they are based right here in the Mannheim-Frankenthal area, and as a bonus, they almost speak my language. That's why I'm especially pleased that the company Brer is here today from time to time. So, as I mentioned previously, we will go ahead and get started in our usual manner. We'll log the data set again and then perform the initial measurement. My colleague will take care of that again. As always, we'll take a quick look around the truck. I am also going to raise the speed limiter again at this point so that we can completely rule out the influence of the top torque system and accurately measure the resulting torque increase, specifically when we are in 11th and 12th gear. The top torque feature means that from 1st to 10th gear, the truck has 2,200 Newton meters of torque, and in 11th and 12th gear, this top torque provides it with an additional 200 Newton meters. So in 11th and 12th gear, it simply has more torque and pulling power available. Now, if you look at it precisely, when the vehicles have top torque, I'm at 2,400 Newton meters, which actually puts the output just over 480 horsepower, but we will take a closer look at that on the test bench. I'll show you this briefly on the laptop. It's important to note that not all models have the top torque curve. It is generally more common in the Euro 6 and Euro 5 models, and less so in the earlier ones. It always depends a little bit on the specific drive system. As you can see, if I have straight axles or planetary axles, usually with AP axles, these vehicles do not have top torque. So from bottom to top, in every gear, they always have the same amount of torque. There is no change. I've talked to a lot of customers, and when they do have this top torque, it's often the case that when you're driving into the mountains and it gets stuck in 11th gear, and just before the crest of the hill, it can't quite make it. So you are forced to shift down to 10th, and then you lose those additional 200 Newton meters of torque all over again. And that is the point when it really starts to struggle. So for this reason, I'm often a fan of adjusting the top torque curve so that from 1st to 12th gear, you really have the same consistent torque throughout. Of course, the first gears are stepped anyway, so there's already a torque reduction there, but starting from the main gear group, you really have the maximum torque available to you. This engine is available in the axle with up to 2,800 Newton meters of base torque, and the engine is also used in industrial aggregates. So the engine is in fact from the factory at Mercedes-Benz, already designed and built for 580 horsepower and 2,800 Newton meters. The main focus here is on fuel consumption, so we need to take a close look at what we have in the initial measurement. This particular Mercedes MP has now run a good number of kilometers. It's a 2016 model year, which might be interesting for you to see what kind of performance a vehicle like this still has after a certain amount of mileage. They're also known for having a slightly larger engine displacement today, but as I have said, we'll take a look at it, we will measure it, and then we will see the results. Here again, we have the eddy current brake for the test, and we have secured the truck at the back again. We usually always use chains, but now When we're securing the vehicle, we've also gotten ourselves heavy-duty straps, so 10-ton rated straps. And we double secure because we found that during measurement, when we secure with straps, the vehicles can actually be measured better since the chains are actually too rigid. So if I have really heavy vehicles on there, like truly 30-ton vehicles or with an empty weight of 28 to 30 tons, of course, then we also secure the back with chains. But in this performance class, since it's already secured below via the axle body and pulled down another 5 tons with the hydraulic cylinder, so it has traction. With the 2 times 10 tons, you basically have 20 tons of securing, which is actually sufficient in principle. So it's really just about that point. If you want to move forward, that's when we secure it at the back. All right, you can see here it's open down here, so you can take another look at it. Down here you can see the hydraulic cylinder, so you can get a good look at it from below. You can also see there's already quite a bit of dirt in the pit. Unfortunately, with the EKW, it just gets driven down there. So I'd say let's start the initial measurement now. My colleague Bastian will handle that again. Now let's go ahead and take a closer look at the measurement we are about to perform. I will be lifting the PetMark device in just a moment, and as I mentioned before, we will then move on to the initial measurement itself. For context, my colleague has in fact already performed 2 or 3 separate measurements while in 10th gear, but for our purposes we are going to quickly conduct a manual measurement here, also in 10th gear. And the reason for this is so that we can briefly demonstrate the procedure and show the results using the top tag. With Mercedes, I can set the maximum speed to 150 kilometers per hour. That's the limit the control unit allows. Also, the truck has a relatively long rear axle, so it really gets tight as we approach the maximum revolutions per minute in 12th gear. It's difficult to measure precisely there. There we have the direct gear, and we can also see from the top torque curve what the actual difference in torque is, but it doesn't really matter. I can actually stop the measurement earlier. For us, the only thing that matters is this torque difference, so you can see live what actually happens in 10th, 11th and 12th gear and what the real difference is. So now we're going to accelerate in 12th gear, around 150 kilometers per hour is of course a brutal speed for the tires. The truck could probably go a few more kilometers per hour, but as I said, we don't want to push it because it's still a dangerous thing to do so many measurements in a row with hot tires at such high speeds. That's not really necessary. As you can see, I've already maxed it out. At 1,700 RPM, the truck cuts off. So you can see up here, I'm in 12th gear. Maybe you can pan over once. You can see from the speed, it doesn't go over 130. Even though I've actually set the Vmax to 150, the control unit doesn't allow more internally, so I can really only measure properly up to 1,600 RPM. So let's just take a look at that. We'll just do a run-up measurement, let it drop off, and then start the measurement at the right RPM. I apply the brake, build up torque, then release the measurement. Now we rev from bottom to top again, up to 1,700, and then let it coast down. So you can see the curve at the back, FT basically, because we can't measure any further out. As I said, unfortunately that's just how it is, but you can clearly see here the lower curve, the blue lower curve, that's the torque. And you can see that in 12th gear it has its 2,000 433 Newton meters. So this increase of 200 Newton meters, but we've only measured twice, just so you can also see the lower gears measured like 10th. In 10th gear, we had a reading of 2,150 Newton meters there. So you can see that the 200 Newton meters of difference is in fact quite accurate. This is also true even in 12th gear, where the maximum torque comes in relatively early. So basically I can now go ahead and align the top torque curve and the curve in 10th gear with each other. Now we're going to go ahead, log in again via the app, log the ID, then pull the software data, which will then be uploaded online to the servers. I can then download it, and I'd say we'll see each other again at the laptop in a moment. My colleague Basti is handling this now. He's logging the ID for me so we can watch him briefly, and then we'll program the IKB together again. Here we have the dongle again, which we plug back into the OBD port down here, gently, not with force. So let's get started. So to begin, we will open the Schaknat application again, just as we usually do. Then we will navigate to the Mercedes-Benz section. It's crucial to remember that the vehicle's ignition must be turned on. This is always a very important step. From there, I will go to open the settings menu and then proceed to the Bluetooth section in order to connect the adapter. As you can clearly see on the screen, we already have a number of different dongles listed right here. This is the 962, and as you just saw, it establishes a connection relatively quickly. Up here at the top, there is a small Schaknat logo that you can use to go back, and then it will connect to the vehicle automatically. Here we find it's the exact same principle once again. I can go in, assign my specific customer, and add the vehicle. For example, this particular feature is also very important for fleet managers. If they have several vehicles or have optimized them, they can use their question number, license plates, or their IKW assignments to enter their data themselves and then flexibly program back and forth, including performing software updates and such. So basically, it's really simple. Then we go back again. So this number here, I already have it online on the server. For me, that's the software number, that's the important one. You can also see here again that the error memory is all stored. All right, now I am going to go in and program the top torque curve. I've already had the opportunity to show you that, but now we'll take another more detailed look at it together on the laptop so we can see exactly how it's done and program it together step by step. After that, we'll program it back in via the app, and then we'll do another baseline measurement. Here you can already see the new premises directly from the test bench. This is their development room. You can see our workstations here. It's not all perfectly set up yet, since it's only been here for a short time, but at least you get a first look. The software has already been set up to some extent. Maybe it's quite interesting for you to see this now. Now you can see here again, I can adjust the line so you can see it better. The two curves here show this top torque, so for the 10th, 11th gear and the 12th gear. These torque increases, as you can clearly observe in this instance, the IKW was originally supposed to have a value of 2,200. However, with the top TA, that value is now 2,400. So you can see the torque curve runs like this again here. Then it drops off relatively quickly. At 300, it falls off quite sharply. That's how it is in the higher gears. Now, for comparison, we can take another look at the lower gears. You can see here, it has its 2,200 at maximum torque. These are purely torque values, and above again are the RPM axes. And here you can see, for example, that it holds in the lower gears. It maintains almost maximum torque up to about 1,450, and only then does it start to drop off. Now here again, we can go in and program this freely, individually. So what I can do now is go in and make both of these maps completely identical. I can also create a nice gradation right here. The truck, as you can see, already has some mileage on it. So here it's really all about saving fuel, and that is the reason I spoke with Schäfer. The increase in power is a nice side effect, but in this case it is really and primarily about the fuel savings. And that's why we're going this route now. So I'm only going to increase the maximum torque by 200 Newton meters here, because that's more than enough for fuel savings. If I use these additional 200 Newton meters as an increase, I'm still completely and safely within the engine's established durability limits. The engine itself, or rather the engine goes up to 2,800 Newton meters of torque which is used in internal industrial engines and also in industrial units. So I'm not worried at all about the engine or the transmission. It's designed purely as a long-haul vehicle. It will never see heavy-duty applications like, for example, on a construction site. But if we stick with these 2,600 Newton meters, so the extra 200 in top torque and in the lower gears, we can adjust that now. We can certainly do that if we want. However, I would still keep the ratio the same so that drivers, especially regarding tire wear, for example, in city traffic or when pulling away from a traffic light, do not experience any increased tire wear. So for that reason, I would just keep the ratio the same. I have kept the lower curve the same in proportion with these 200 Newton meters. But again, for customers, we can program this on an individual basis. We can do more or less. We can set the torque lower if the customer says, look, I only want the torque at the bottom. We can really adjust this individually for each of the customers. I've also found from experience that the magic threshold is at 300 Newton meters. If you go above that, fuel consumption tends to get noticeably worse, sometimes even significantly so. So between 200 and 300 Newton meters, if we stay within that range, you always get great performance and great fuel efficiency. But since this is purely for long distance transport, those 200 Newton meters are more than enough. The idea is really to ensure longevity. The trucks should easily run 1 million kilometers, and that's how we optimize things, so that wear and tear remains low. All right, I'll set it up like this now and then flash it back onto the system with the app. Let's take a look at the baseline measurement. We can also measure in 10th gear again, since the ratio will definitely stay the same, so we can extrapolate from that. We'll end up with about 2,600 Newton meters at the peak torque curve, and in 10th gear we'll be just under 2,400 Newton meters, or 200 Newton meters, as I said. We'll also optimize the transmission again so that everything is perfectly tuned to each other, so the gears shift more smoothly, and those jerky shifts, or for example, when you approach a traffic light and the transmission starts downshifting and slams the gears in, we'll program that out in the app as well, using the QT values. All right, so I'll see you at the IK again. I've just connected the dongle again, got back into the vehicle, and now I'm going back into the engine control unit. I've already flashed the eco optimization to keep the video a bit shorter. So normally at this point, you would go ahead and flash the eco optimization. After that, today we're going to go ahead and flash the transmission optimization as well. We can do that quickly now since it goes faster. You see it's already done, and it tells you to turn off the ignition again. Now we've done the eco optimization for the customer with 200 Newton meters and still kept the power at 300. So this way he can decide for himself again what he wants to drive. That's entirely up to my customer. We'll take another look at that in the baseline measurement. As I said, you've already seen in other videos that the changes are always pretty spot on with Mercedes. So now, depending on engine variants, we'll end up somewhere between 200 and 220 in terms of power, I think. All right, let's just go ahead and do it again. I'll clear the error memory again. Down here, I'll also read out the error memory DTCs again. Now, it looks like there aren't any errors in there at all. So let's reset it again just to be sure. Exactly, then we go back once again. And when the start screen appears again, it is very important, as I've said many times before, not to log out, but to simply close the application, and then we will be able to perform the baseline measurements. Then you can disconnect it here again. As long as it's not communicating, I can always go ahead and disconnect the toggle. So it's important to only disconnect bottles or anything else so that we don't accidentally create any interference. All right, then we'll measure again. All right, we're going to perform the next step right here. And with that, we have now completed the initial baseline measurement. This is a critical part of the process because this measurement provides our fundamental starting point, the foundational data against which all subsequent results will be compared. Without a clear and accurate baseline, it would be impossible to meaningfully quantify any effects that happen later on. So, by capturing this initial value, we have established the benchmark that will anchor our future analysis. 10. I rechecked in 10th gear. 12. I didn't do 12th gear anymore because we can't get a clean measurement up there. Now we can see it up here again. I'll explain it very briefly. The lower curves, the bottom 3 curves, that's the torque. That's actually what's important for us. The upper ones show the peak power. Of course, people always want to know how much horsepower it has, but for us that's not really interesting. For us, it's more about the torque at the bottom end. So you can see it now as well. Now, with the pink curve, we have 473 horsepower and 2,371 Newton meters of torque, which is about 200 Newton meters more compared to 2,150. So, as I said before, on average, we have between 200 and 220 Newton meters more torque. And I can also clearly see it on the blue curve that this increase is top torque. So basically, this means now I already have the same power in 10th or 11th gear that it had before in 12th. It had, but of course I also have to add this increase now, so the starting output is 2,650 Newton meters of torque. The peak power, you can see it up there, as I said. Don't always let yourself be guided by this upper power, by this kilowatt rating, because the rated kilowatt is actually totally irrelevant. I mean, I measure the kilowatt output somewhere. You can look it up in the vehicle registration. I measure it somewhere at 1,800 revolutions per minute, 1,700 revolutions per minute. And I'd say in a long-haul vehicle, I'm not operating in that range. If I have a heavy-duty truck, for example, sure, they rev higher because they need those revolutions, but they drive at completely different speeds. For them, it's more about overcoming steep inclines, so they need the high revolutions per minute along with the high kilowatt output. But for us in long-distance transport, it actually plays a key role in saving fuel. You can see it has a completely different torque at low revs. So again, the truck will now shift up much earlier, and it will shift up more smoothly. For the driver, especially when exiting a roundabout, you know this with the Actros, when you enter a roundabout and it shifts back and forth randomly, this really solves that problem well, because it holds a gear and you can drive around the roundabout without it starting to shift wildly back and forth again. That also saves fuel, reduces wear. Every time the clutch opens, that's more wear. So what we are trying to do is to ensure that the vehicles have to shift as infrequently as possible, so they can stay in the higher gears for as long a time as possible in order to avoid all that downshifting. And as I said, that makes the vehicles more durable and reliable. As I mentioned, I am genuinely happy with the base performance. I just wanted to quickly demonstrate for you today exactly what it looks like with top torque, that here on the test bench, when you measure it at the top end, we also reach our absolute limits because the control units just simply do not allow any more at the top. And as we have already said, it is also a potentially dangerous thing to measure at 150 or 160 kilometers per hour at the top end, because if a tire bursts on the test bench, that is not a pleasant thing, not good at all. So that about covers it for this topic. We will leave the truck exactly as it is. The customer will also receive the dongle now, so he can change the performance variants himself, and I am really satisfied with how it has turned out. We are at the end of our video again. As you have seen today, we also carefully consider how to optimize the trucks, tailored specifically and individually to the fleets, and how we tune the vehicles. As we've already said, durability is simply extremely important to us. Brugger is, I believe, one of my very first and earliest customers here in the region, and I've been working with them for a really long time now, over many years. As you can see, we've worked together on 7 or 8 different machines, and the customer is still with us, which also shows that our company really brings added value to businesses, whether it's lower fuel consumption, better driving experience, or improved shifting for the drivers. As I mentioned before, the customer will also get the app again, but it's probably going to be the junior boss at Brugger who will handle it. He'll flash it with the app, since he's also a bit tech savvy and interested in technology. Brugger is a family business that's been around for quite a while now, with a long tradition. We'll also include a Hugo Boss Toothbaum for the driver, just a little something extra for the drivers, so there's something to look forward to. If you're interested in this topic of engine optimization for the Mercedes Actros 1845, feel free to check out our website at schaknat.de. You can also call us, send an email, or message us on WhatsApp. As I said, a phone consultation is often a bit easier and more direct. If customers are really interested, we can answer many questions individually, since a lot of things are quite specific and unique. I'm glad you tuned in again today, and I appreciate your interest. Please keep subscribing to our YouTube channel. That makes me really happy as well. At least then we know that people are genuinely enjoying it. And on that note, thank you very much for watching. See you next time. Thanks, bye.